Hi guys, so today we're going to talk about stoichiometry. So more specifically, we're going to talk about limiting reagents and percentage yield. So basically, a limiting reagent. What is a limiting reagent? It is the substance that finishes first, basically. So if you have two substances, whichever one is completed first, basically is the one that determines how much product is formed. So we'll see that in the problem later on. And percentage yield is, so limiting reagent is just like the name of one of the substances, either group A or group B, whichever one finishes first. Percentage yield is a different concept. It's the percentage in which the reaction happens accurately. So how much is really yielded from the experiment, not the theoretical yield, not how much you calculate, how much actually happens. So in case other atoms react with other things, or it gets a little more confusing. But this is a formula, which is actual yield. So this is the number, obviously, over theoretical yield. Yield multiplied by 100. So theoretical yield is determined based on the limiting reagent, and actual yield is what is given to you. It must be given to you, or else you can't really calculate it. It's usually given to you though. Multiply it by 100 and you get the percentage yield. Okay, let's do some applications of these. Calcium carbonate, CaCO3, is able to remove sulfur dioxide, SO2, from waste gases by a reaction in which they react in a 1-to-1 stoichiometric ratio to form equimolar amount of CaSO3. So basically what they're telling us here is our reactant and our product. So let's write that in a chemical formula. So we have, let's make this white. All right. Okay, so we have CaCO3, and we're adding that to SO2 to form, and this is a 1-to-1 stoichiometric ratio, to form equimolar amounts of CaSO3. Okay, but here we notice that we have, well, I remember we did this one in class. Side note, this is not from my own knowledge. We added a CO2 here to our products plus CO2. Why, you might ask? Because we have an extra C and an extra O2. This 3 went over here and we're left with some extra things. So Ms. Zainoun told us to add a CO2. So we just do that. All right, so here is our chemical formula. Okay, let's continue. When 255 grams of CaCO3, so we have 255 grams of CaCO3, reacted with 135 grams of SO2, 198 grams of CaSO3 were formed. 198 grams. So what is this number? Is it the actual or the theoretical yield? I'll give you a minute to think about that. It is the actual yield because they gave it to us in an exact number. So we have to determine the percentage yield. So the steps to determine the percentage yield go as follows. First, we must determine the limiting reagent. By the limiting reagent, we mean the substance that is completed first. So to do that, we'll have to use our chemical formula. We're going to choose any one to start with. We're going to start with 255 grams of CaCO3. And we're going to see how much and which one is really the limiting reagent. So we're going to calculate some details. Ca, I believe, is... let me just check that out really quick. I believe Ca is 30, 35, 32. There we go. Ca is 40. Oh, no, we're even close. 40.08 grams. And we have a C. It's 12.01 grams. And we have 3 O's, which is 48 grams. We're going to add those together. Over here, 12.1 plus 48. We'll get 100.09 grams of CaCO3. So that's our molar mass. CO3 is 1 mole of CaCO3. Now, 1 mole of CaCO3, we're trying to find out which one is completed first, whether we have more or less than the given. So for 1 mole of CaCO3, we have 1 mole of SO2, correct? So we're looking at this formula. We have 1 mole here and 1 mole here. So basically, we're trying to see the relationship between these and how much of this we need to get to this, how much of this we need to get to this. It'll all clear up at the end. Don't you worry. Okay, so 1 mole of SO2. Now, in 1 mole of SO2, we have, now we gotta check out sulfur. I believe it is, sulfur would be 32.07 grams and 2 O's, which is another 32. Therefore, we have 64.07 grams of SO2, which is 64.07 grams SO2. Now, that will give us, okay, 255 times 64.07 divided by 100.9. 161.92. Okay, we're gonna go for, it's 4 sig figs. So grams of CO2. Okay, so what is this number? This number is the grams of SO2 needed to complete this reaction. It's the grams of CO2 needed. It's the grams of SO2 that are needed to react with 250 grams of CaCO3 in this reaction. Now we're going to ask ourselves, is 161.9 grams of SO2 that is required by this reaction, is that more than or less than what we have? It's less than what we have, so that means it's the limiting reagent, because it is the one that is going to finish first, because we have less than required, so it will determine how much of CaCO3 is needed and how much will be excess. All right, so now that we have that out of the way, we know which one is going to determine the product amount. We can use that. So here we're finding the limiting reagent. So number 2, what are we going to do after we have that information? We are going to find the amount of product. All right, so how much CaSO3 can we make with our product? Yeah, because here in the question, they ask us to determine the percentage yield of CaSO3. Right? You have to make sure you don't confuse the CO3 with the SO3. Okay. Anyways, going on. We're going to use our 161... Oh, no. I'm sorry. We're not going to use that. We're going to use our 135 grams. Let me do this in another color. We're going to use our 135 grams that we have right now to determine how much product we're going to make. So we have 135 grams of SO2, which is our limiting reactant, and 1 mole of SO2 is, how much did we calculate? 64.07 grams of SO2. Now, for every 1 mole of SO2, we have 1 mole of CaSO3. Is that right? Yeah. Okay, now for every 1 mole of CaSO3, we have, oh no, more calculations. Okay, we said our sulfur was 32.07, I believe. Right, let me just make sure. Yeah. Okay, we have calcium, which is 40.08. Wow, I'm raising them. Okay, and 3 oxygens, which is 48.0 grams. All right, where's my calculator? Here it is. I'm going to do 32.07 times, oh, not times, plus 40.08 plus 48. 120.15 grams. 120.15 grams CaSO3. Now, whoa. Multiplying all of those, we're going to have 120.15 times 135. Take that answer, divide it by 64.07. I'm going to wind up with 253.2 grams of CaSO3. Okay, so this is our, you know what this is? This is our theoretical yield. So this is how, if everything went perfect in our reaction, how much we'll wind up with. So now we have our actual yield, we have our theoretical yield. All we need to do is put them into the formula and see what happens. So formula says, oh, where's the random Ca here? Formula says actual yield over theoretical yield times 100. So we're going to do that. Actual over theoretical times 100 equals our percent yield. Putting them into the equation, we're going to have 198. 198 over, what is happening? What is happening? Okay. We're going to have 198 grams over 253.2 grams times 100. I'm going to calculate that real quick. 198 divided by 253.2 times 100. You'll get 78.1, well, 78.20%. That, my friends, is our percent yield of this equation. Oh, this is the percent yield of CaSO3. Yeah, thank you for listening. I hope this helped. Bye.